Hey, welcome everyone to our webinar. I'm just watching the participant count creep up, so I'll give it a few more seconds to let people join. All right, I think we'll get going. We've got a good number here already. So welcome everyone to the webinar. My name is Katie Coleman. I'm the Managing Director for Equal Experts North America. Today we're talking about AI in the SDLC, from experimentation to real life delivery impact. So thank you for taking the time to be here. Just as a quick introduction, one of the consistent challenges we're seeing at the moment is how do you scale AI and software delivery? So this is really about moving beyond individual engineers or product managers using an AI tool with some good prompting to moving into more a repeatable, governed, embedded practice across a single team and multiple teams. So my colleagues Andy and Mike are going to talk you through a practical approach today, including a demo. We'll be using Claude Code for that. But quickly, before I hand over to them, I just wanted to give you some context about who we are, Equal Experts. We're a global tech consulting company. We focus on helping large organizations deliver better software faster with less risk. And really, what makes us different is our model. We have a senior only team. So about 90% of our people have 10 years of hands-on experience or more. In fact, there's lots have 20 plus years. So we don't have juniors, we don't have a pyramid structure that a lot of our competitors have. And we really work directly with our customers' teams, working side by side, embedded. So that means we're much closer to the outcomes rather than providing advice from a distance. We're employee owned, which we're very proud to share. So we don't have some of the same external investor pressure that other companies have. So it means we don't overemphasize on growing from a financial perspective, but we start small with our customers, build trust, and go from there. So today, we're not trying to sell you a product, but this is really about how AI changes the way we build software itself. So that's across engineering, product, testing, documentation, and so on. So we're really seeing firsthand with a lot of our customers that even though they're seeing some results, it's kind of patchy, and they really want to see some more consistency across that. So on that note, Andy and Mike will be sharing everything with us today. We'll run for about 30 minutes, and then we'll have 15 minutes of Q&A. So please use the Q&A function. You can drop questions in there at any time, and you can upvote other people's questions. So go through that, keep an eye on it, and then we'll revert into that after about 30 minutes. Okay, over to you, Andy and Mike.
Thank you very much, Katie. Hi, everyone. Thank you so much for being here with us today. My colleague Andy and I are going to talk about a really popular topic that Katie has already mentioned, using AI to develop software. Everybody's talking about this, but we have our own perspective we'd like to share on that. And specifically, we want to talk about the challenges that enterprise companies have in adopting AI for software delivery, and it introduced some keys for moving beyond those challenges. So first, let's just a quick intro. I'm Mike Mitchell. I'm product and strategy principal for Equal Experts here in North America. I've spent 30 years in enterprise software as an engineer and a product management leader, building and leading world-class product teams.
And hey everyone, I'm Andy Vase, technical principal here at Equal Experts. I've spent my career leading teams and working hands-on with enterprise platforms and engineering teams. Really excited to be here today and share how AI has transformed how we work and how we've helped our clients transform how they work.
Thanks, Andy. All right, so let's just dive into the problem. The problem we want to talk about is that enterprise companies are not getting the results they hoped for from AI and software delivery today. And there have been industry reports about this since last summer. You may remember the often quoted MIT report saying 95% of AI projects aren't really producing any return. And there have been more reports, even though that has been debunked a little bit, there's been a lot more reports about the same problem since the first of the year, confirming that this problem is really still happening. And it's a little like setting out to bake this fancy gremlin cake and ending up with whatever this is. Companies are just not getting the full effect of using AI in their software development lifecycle. So we've been exploring this problem a little bit more deeply with companies that we know, and we've seen that they tend to fall into one of these four stages of maturity. There's unaugmented, which is where we all started, and where we were several years ago now, before AI, just using standard human processes developing software. Initial steps towards adopting AI tend to start with giving individual team members subscriptions to an AI tool. For example, Copilot is a common example, and letting them build in their own way. The phase beyond that is cross-functional teams using AI together with intentionally designed structure and workflows and some shared methodology. And then, of course, the vision that we all have is the agentic future where AI anticipates and delivers on our needs with minimal direction. It still produces high quality code, but very few organizations are close to that today, really. What we hear from most organizations is that they're currently stuck somewhere between individual and team augmentation, and they're struggling to move beyond that. And there could be many reasons for that beyond simply not knowing what to do technically to achieve that, from politics to cost to security concerns. And we don't intend to minimize the difficulty of solving for those. But if you can just take that next step towards maturity with team adoption of AI, you can really start seeing the real benefit of AI at scale. So I'm going to turn it over to Andy now to introduce some key ingredients to start making that move.
Thanks, Mike. And so after working with AI across clients, we've really seen a consistent pattern. And the gap between expectation and impact isn't really about the language model. It's a lot more about the operating model and how you ultimately put this new delivery stream into practice. And so if you want AI to accelerate software delivery, three foundational elements have to be in place. First, shared context or knowledge. AI can't operate in a vacuum. It really needs explicit version knowledge about your architecture, standards, and domain to get the optimal result. Second is governance and rules. Clear guardrails for where AI can act, how it should act, and the constraints it must follow when it produces output. And third, experts in the loop, or architects in the loop, or humans in the loop. But AI augments, it doesn't replace judgment. Your architects and engineers define intent, define the trade-offs and the approval points at the right stages. And when you get these three things working together, you get repeatable, reliable impact. And so let's dive first into shared context and what we mean by that. And so when we say shared context, we're not talking about documentation for documentation's sake. Shared context is a living understanding of what you're building and why. Product intent, domain rules, architectural decisions, and constraint. Think of it as your product or your organizational blueprints that not only humans can understand, but AI can as well. And so most of us throughout our careers have probably experienced different artifacts, systems landscapes, product specs, journey maps. You produce it and they go stale almost the minute they were produced because no one really keeps it up to date. With AI, not only can you keep it up to date, but it's actually critical and foundational to getting the most out of it. And where that context lives really does matter. And so we've heard a lot about MCP and going out externally to grab information and pulling it into the work stream. While you certainly can do that, we believe context needs to live within the repo or exactly where the LM can grab it in a language it easily understands to avoid delays, avoid context noise, and really streamline what it's accessing and what it means and how it's using to shape its outcome. And so again, context can include your code, your tickets, your design artifacts, but it really needs to be intentionally structured, curated. And you'll hear this theme said throughout this presentation. When you're delivering a feature, delivering something new, it's not just about being code complete, it's about being context complete as well. And so when you're merging your branch, you're not just merging your mutations to the code, but you're also merging the mutations to your context. And when you treat context this way, it really becomes a connective tissue between AI and people, and it helps keep things aligned. One question I get asked often is, this is great, AI is helping you build code, but what happens when something breaks? What happens when institutional knowledge fades or the system evolves beyond what anyone remembers? And the answer, again, isn't just shared context. It's context that's been continuously maintained and embedded into the development lifecycle itself. And when these become living artifacts that evolve with the system, they become a reliable source of truth that you can then plug into either your developers or to an LLM. And so when there's a bug, a production issue, a new feature request, you can feed that up-to-date context to the LLM and it understands exactly what the current state of the system is without having to go search through code and search through documents and external systems. And this is what helps to really keep AI aligned with reality. It helps prevent drift and stale assumptions, and it helps to make recommendations that reflect how the system actually exists today and not how it existed months ago. And so this is just an example of what we mean by context. Usually a markdown file. It's explicitly curated. It can be derived from external artifacts in the form of synthetic data that it represents, but lives in your code base. It's explicit and brief, but generally pretty information dense because it needs to contain all the relevant pieces of information that the LM will need to understand whatever piece of context you're looking at. And then, as I mentioned before, going externally via MCP or API increases complexity and most importantly, floods the context window potentially with noise or unnecessary information that might actually shift and alter the output you're hoping to get. And so our next principle is governance and rules. If shared context defines what we know, governance defines how we actually operate. So it's not about prompts, it's about being explicit. Standards, templates, guardrails, CI checks baked directly into the workflow. We keep these again in the repo along with the code because that's where execution happens, and it makes it easy for them to grab it and use it while it's working. And the goal isn't to micromanage AI, it's to remove any ambiguity before it acts. And you're going to see that as a consistent theme as we talk about specs and spec-driven development. It's really shaping the input so you get the output you're looking for. And when you do that, the output stops being random and it starts aligning with your architecture, your security posture, and your standards. And this is what ultimately enables scale, not just within its use, but scale across the team. Because when you have a consistent source of truth for both your context and your skills or your rules, now you can have different teams operating in a common way, all adhering to the same organizational and project level standards, while still allowing flexibility to shape what they're doing at a more micro level if needed. And of course, these are always curated and defined by your architects and experts, and they evolve along with the code as well. And so again, here's an example of governance and rules. It's just a markdown file. It lives in your repo. It's explicit and intentional. It's curated and maintained by your experts. And most importantly, it's maintained and updated regularly. A question I got asked previously was, what happens when our security policy changes at an organizational level? That's a perfect example of how you want to be able to take that global organizational change in security posture, standards, requirements, and make sure it gets cascaded down and reflected into your rules and governance so your teams are now operating under those new constraints. And then our last principle is experts in the loop. Notice the play in our name. That's not accidental, but of course you're experts and architects, but it's really accountability by design. And so as AI takes on more execution, there needs to be explicit points where humans own the decisions, trade-offs, and risks. Because when something goes wrong, accountability doesn't sit with the model. It sits with the organization or the operator who ultimately produced and checked in that code. And the challenge with AI is it often looks good enough at a glance, and it's really tempting to just accept its output. But that's exactly where failure creeps in. So the goal isn't exhaustive manual review of everything. It's defining where judgment matters, design intent, product decisions, architectural decisions, risk acceptance, and embedding those checkpoints directly into your workflow. And you'll see us demonstrate parts of that today, both on the product and the delivery side. And when you do this from the start, review actually becomes easier and quicker. AI does a lot of the cumbersome work, and experts really focus on validation and direction. And just as importantly, this builds trust for teams, for leadership, and for clients that AI is accelerating delivery without eroding responsibility. And so we've talked about the problem, unmet expectations for AI, and the three foundations: shared context, governance, and experts in the loop. And with those in place, AI stops being just a coding accelerator, and it really starts changing how we think about the life cycle itself. And the biggest impact is actually upstream before a single line of code is written. And so if AI is going to be grounded and aligned with our standards, that context has to start with clear product intent, clear requirements, and a clear definition of what done and good looks like. And that's where shifting left really begins. So I'm going to hand it back over to Mike to walk through what that looks like on the product side.
Thank you very much, Andy. So the next thing we're going to do is show an example feature moving from definition to delivery using some of these techniques that Andy was just talking about. And we're starting at the left end of the delivery cycle with requirements definition. And here's a process map of what it looks like to use our pillars in this part of the process. And one of the biggest goals in building out this structure is automating the tactical busy work that lots of PMs are tasked with today. And that automation is important for two reasons. First, AI is also accelerating engineering teams. So product managers need to keep pace with that new demand or they're going to become the new bottleneck. We don't want that bottleneck just to move somewhere else in the life cycle. It's not going to speed everything up. Second of all, we need to automate to open up more time for making sure we get the strategy right and also making that strategy more available to AI. And that means spending more time on the activities in the bottom swim lane here that are more strategic and review activities. Remember, AI accelerates you in whatever direction you're pointing. So we need to make sure that we're pointed in the right direction, or we're going to make bigger mistakes and we're going to make them faster. AI also consumes that strategy differently than people do. So we need to build that strategy directly into our shared context so AI has access to that throughout the development lifecycle and understands what strategy it's building towards. So in our swim lanes here, we're showing governance and rules across the top. So these are in the form of AI agents and skills, executing the activities that we're asking it to execute throughout this process. Human in the loop on the bottom, where we're doing strategic activities and we're reviewing the outputs. And we've got the shared context in the middle. So those are those artifacts that humans and AI are collaborating on to drive through the life cycle. And here we are, we've got these in a loop so that we're iterating on those. We're constantly refining them. And in this particular demo, we're going to show the right-hand side of this. So we're not going to show the entire requirements definition process starting from discovery, creating all these initial documents and things. We've already completed those in our repo using AI. We've built all of these things, and we're going to show refining a brand new feature and going through that refinement loop and approval with a human before we feed it into the engineering part of the life cycle. So before we move to that, I just wanted to explain what the application is that we're building on top of. So we're building a feature for this particular application, which is very, very simple. It's a survey application that we built for a previous event. There's a survey, there is an admin page with a login, and that's really it. The admins can just see how many surveys have been answered, and that's all they're able to do today. Very, very simple application. You're looking at pretty much the entire thing right here, and we're just going to build one simple feature on top of this. So before I go into the demo itself, this is going to be a video, and it moves pretty quickly. So I want to describe what we're going to see on the next page before it starts so that you're all oriented. So when I start the video, you're going to see a split screen. And on the left-hand side, you're going to see GitHub, specifically GitHub issues, where we're tracking the feature tickets that we're building for this project. And on the right-hand side of the screen, you're going to see Slack, which many product teams use for communication within the team. So that's what's on the page here. So I'm going to go ahead and start our video. There it is. We've got GitHub on the left, and you'll see a typical Kanban board, which I'm sure most of you are familiar with. And in our Kanban board, we've got our backlog status here, and we're going to create a brand new issue in the backlog to display results for a single survey response. So we want to be able to see a survey response that someone has entered, and we're just going to give it a really simple one-sentence description here. Definitely not sufficient for a typical development story, right? Stories should be much richer than this, but just as an example, for the sake of time, we're going to do a very, very simple story here and show you how we're going to refine this with AI. So we're going to allow someone to see a respondent's answers. And we know that that's not sufficient. And so we're going to check the status to needs refinement. And that is going to tell the system to move this into the needs refinement status. It's going to kick off an automation in GitHub Actions using Claude Code to refine this particular ticket. And you'll see it's started a thread in Slack, and it says it's reviewing the context now. What does that mean? So if we jump back into GitHub for a moment, we've got a context directory in our GitHub repo that has a bunch of things in it. It's got context talking about the business requirements for the product. It's got a product spec for the product that's been built already. So this is what already exists in the product today, including some screenshots there. It's got target personas. It's got our tech stack. All of that context is available for AI. And it's also got our governance in here in the form of agents and skills. And so we've got a product agent that's been defined. It's got a mission that it's trying to achieve. It's got a bunch of resources available to itself to use in accomplishing this goal. Some of those resources are skills, and it's got a Slack conversation skill as well as a story management skill. And the story management skill contains a template for what stories should look like. So that's how it's going to create the stories. So it's finished reviewing the context, and now it's going to start a thread that I'm going to open up, and it's asking me some questions that it needs to refine the story further. And the first one it's asking is, who's developing this? Is it an LLM or a human developer? And we found that this is important because those stories look different. LLMs have all of that context available to them all the time, and they can keep it in their proverbial head. So it doesn't need as much in the story itself. So the format can be a little bit different. I'm going to answer those questions. It's going to come back and ask me more questions. This is sped up a little bit. You don't have to wait for the LLM to answer. So I'm going to answer these additional questions that it's got for me, and it's going to take these back, and it's ultimately going to produce a refined story for me to approve. And here's the story that it sent me. And if we start at the top here and look through, we've got a typical story in a format that you'd expect. It's got some additional business context. It's got some metadata here, acceptance criteria in behavior-driven development format, that given when then format there. It's got some non-functional requirements, some additional quality checks. No open questions notice because we answered those in the Slack thread in our conversation. And it's asking me to explicitly approve to finalize the story. And so I'm going to type approve and send that back. It says it's been refined and labeled, so we should see it show up in the refined column now. And if we open up the story, it's now populated that issue with the story that we've just approved. In the comments, it's got a checklist. It's showing what it accomplished in the Claude automation, and it also has a conversation log that shows the conversation it had with me in Slack, with timestamps and who it was conversing with, as well as the story that was approved. It's right in there. And my official approval that this is what I wanted to go into the issue, so that we've got an audit trail now of everything that AI helped me with in producing this particular story. And so now it is ready to turn over to engineering. And before I hand it back to Andy, I just wanted to mention that I recorded this in real time. I cut out, as I mentioned, kind of the long waits, waiting for the LLM to come back to me. But other than that, it is exactly as I went through it when I recorded this. In real life, it just took about 10 minutes or so. It cut it back to about 5 minutes with the additional part added to walk through the context. So it can move very, very quickly when you're using AI to kind of take out all the burdensome, cumbersome pieces that you're normally dealing with on a day-to-day basis. So with that, I'm going to turn over to Andy to walk through the rest of the process.
Thanks, Mike. And what I love about that is we're not just shifting the workflow left, we're actually shifting how we engage further left to our stakeholders. I don't know if you've ever experienced a stakeholder that you just can get to go into Jira and update a ticket or refine one. But that's one of the great things about AI is you can actually take that whole workflow, simplify it, and actually move it to where they're already working. We use Slack, but you could have just used Teams. But I really enjoy that part. So thank you, Mike. All right, cool. Back to the engineering fun, right? And so our next step, now we've got a well-refined feature, is to get back to the fundamentals of software development, which could be a little boring for some, but I think it's really important here as we work with AI. Because before we write any code, human or AI, we want to be explicit about what we're building and why. And that's the idea of spec-driven development, the term I'm sure most of us have probably heard before. And if you think about how teams evolve from more waterfall style delivery into agile, some of that rigor naturally got lost. We optimized for iteration and speed and relied on people to fill in the gaps as we went. And that worked when humans were doing most of the work. But with AI, it doesn't quite work the same way because you don't really want the AI filling in the gaps and making assumptions. And so bringing that discipline back isn't about going backwards. It's about creating clarity and intent before asking it to execute. The spec itself becomes a checkpoint. Experts or architects can review it, validate direction, catch issues early on before coding anything. And once it's defined, it doesn't matter whether a developer implements or an LLM, you're creating something deliberate and intentional. Um, and again, this is just an example of what a spec would look like. It lives in your repo with your code base. It's a good practice to link it back to the Jira ticket or GitHub issue or whatever item that it's actually solving for. It contains regurgitation of the requirements. It defines how you're going to solve the acceptance criteria, what new classes you might want to introduce. It's essentially a blueprint or a real technical spec that you want to sign off on before building anything. And so once our spec's defined, implementation really becomes a structured, orchestrated workflow. We hand the spec to the LM and it generates the backend changes, the front end changes, whatever the spec called for. And if the spec's too large, by the way, we could break it up into logical pieces, but the flow is generally consistent. Generate code, generate tests, and then validate against the spec. And throughout that process, the shared context informs decisions, governance enforces patterns, and predefined skills keep the output aligned with our standards. Experts then review the results. You could review it in a PR, or you could download it locally to your IDE, run it, approve it, tweak it. And what's really cool about that is if you're using Claude Code or Codex or whatever CLI tool you like, you're using the same context and rules locally as you did kind of with this more agentic stream that we're kind of showing you. And so they actually complement each other. And so if you do want to iterate on the code, you can locally as well, but you don't have to go create a whole new set of context rules and skills. They're already there for you to use and tweak as you go along. And I think this is actually where some of the biggest time impact shows up because we're not spending time writing boilerplate or rewriting code we've written hundreds of times. We're defining intent and guardrails, reviewing the output, and making sure it's exactly what it would have been had we written it ourselves. Oh, perfect. Sorry. So once implementation is complete, we move into validation. The test cases are generated directly from the specification and the acceptance criteria that we defined during the requirement stage. So we're validating exactly what we intended to build. From there, we analyze edge cases, run the regression suite to make sure changes don't break existing behavior. All this is guided by shared context, a specification, test strategy, and the evolving test suite. And importantly, humans stay in the loop. Engineers review the results and approve the suite before any changes move forward. So validation becomes a governed, repeatable step in the life cycle rather than something ad hoc we do at the end. And this last piece I really want to emphasize is what I think makes what we're talking about today fairly unique. And it's the idea of treating context as if it were code or part of your code base as well. And so you hear people talk about context, but for us, it means something very, very specific. The artifacts you create at the beginning of the projects don't become stale. It's not a one-time exercise, it's part of the life cycle. And with every feature release, you're not just merging code, you're also merging the context updates themselves. So if you're just new endpoints, DTOs, architectural decisions, your architectural docs get updated, your specs get updated, and your context files get updated. And a feature isn't complete until it's code complete and context complete. I really want to emphasize that point because that's when this becomes really powerful. You end up with true end-to-end traceability from the original requirement to the spec that satisfied it, to the code that implemented it, to the updated artifacts that describe the system. And that's something a lot of organizations have not yet mastered, this idea that it's a full cycle thing as opposed to a linear development workflow. And when context evolves with the system, you minimize drift, you can see what's changed, why it changed, and you can all understand the gaps that were ultimately closed by delivering a feature. And so I'm going to take you through a really brief demo here of what that looks like practically and how easy it is to do that. So Mike, if you don't mind hitting play, please. Fantastic. Cool. And so as Mike showed you earlier, we have agents. In this case, we'll create a specific context manager agent. We like to use agents sometimes for specific tasks because you could do unique things. They run in their own context window. They could call other agents. You could also specify which model you want to use for a task. So your context agent, maybe you want to use a more in-depth reasoning model just so it can better update the skills and context. But ultimately, it's the agent definition here itself, and within it, it says which skills to use to manage context. And here again is our context management skill. It talks through the core principles, what it should look for its source, where it should be putting the updated context files, whether it should be updating your Claude.md or your Copilot.md files, right, depending on what you're using. And then, of course, here is like our context directory itself. We kept this shape generically just for the purpose of this demo. Claude kind of wants you to do one way, and Codex wants you to do a similar way. But ultimately, it's just markdown files in a repository, usually with an index file that's showing you what files govern which process. But these are, again, maintained as the final step of our release pipeline once we're happy with both the code and the validation. Just kind of showing you what like a teaser of an agentic future looks like, right? And so we have this all hooked up to GitHub Actions, and so they're triggering actions that call our agents that effectively generate the context or do different phases of this of our life cycle here. And then what's really cool is when you then come back to your feature branch, you get a full record of everything that's really happened along the way. And so you can look at this feature branch, and it has the spec that was created, it has the code that was created and the commit related to it, the QA that was created, and this final step here, which is the context that was ultimately mutated to represent the changes that were created by that feature branch. And it's all self-contained and self-referencing back to the initial request that asked for it. And so kind of just bringing this all together, right? This is an example of what maybe a very forward-looking agentic lifecycle might look like. In the magenta, you have kind of your agents facilitating things, and you have your context there at the bottom and at top in sort of that aqua blue color. You have the different skills and governance that are shaping the output as you work through this delivery stream. And what's really cool is when you create these foundations, it's helping us develop code as part of what we just showed you. But what it also does is it enables you to really shift the process further left, and you leverage the same context and skills in other places that you might want to work. My favorite example is prototyping, right? So if you have the context and it has your like design artifacts in there, and you have your skills that have your design, your different media guidelines for how to produce stuff. You could use something like Figma Make or other tools and start prototyping, or product and the business side can start prototyping and seeing what they're asking for, how it could look and feel, and it could remain consistent with everything else that you're producing. So that could be an additional artifact they could hand further downstream to eliminate any ambiguity and validate the user experience themselves. And as you can see, there are different steps here with orange representing the different stages where humans should be making decisions. And one question I get is, what's the big difference between this and how we work today? This is, if you could imagine agents or an agentic workflow pulling work as you go from left to right. You could have humans doing all those magenta boxes where you see agents, totally fine. You could be doing that in your terminal using the same context and skills. But I know a lot of folks are imagining a world where you wake up and you have a PR to review, and you end your day by reviewing the code that got generated along the way. And so this is just kind of bringing everything together and giving you guys a full picture of what life in the future might look like, or in the present for some forward-looking organizations. And so last but not least, I really want you all to kind of think about what this slide represents. Context as the foundation, skills as a layer above, agents above that, and human oversight in the middle. And what I think sometimes gets lost on us as engineers and product individuals is what we're building things with that what's immediately in front of us, but we're actually laying the foundation to create an agentic future, not just for development, but for the organization as a whole. Because the context and skills we're creating might be useful for development, but the marketing user might also want to tap into those same context files and skills when they're creating their journeys. Or you might have an executive that wants to understand a product, why it was built, how it was built, what are some of the non-functional requirements or business requirements within it. Well, that lives in the context, and they could just pull up their local version of Claude, tap into this shared context and skills layer, and start asking their own questions about what's there. And so I really want to leave everyone with this kind of picture in mind as we're mostly technical folks, I think, on this call. What we're creating isn't just for us, it's really to help usher in the future state of an agentic world where we're leveraging these tools and these foundational principles to accelerate other areas of work throughout the organization. And so that's it. I just want to say thank you. I'll hand it back to Katie here in a moment, but appreciate everyone's time and hopefully you all learned something.
Awesome. Thank you, Andy. Mike, that was great. It's always good to hear the detail behind all of this. We know there's a lot of talk about a lot of the advantage AI can bring, but seeing this specifically laid out here is really useful. So we've got about 5 questions. We've got just under 10 minutes to respond. So we'll go through those pretty quickly. We've got some votes here, so I'll go in vote order. Starting from a question from Ray. Do you recommend any particular framework like SpecKit or Compound Engineering plugin?
Um, So we try to, well, so we're happy to share what we would recommend, but we generally try to take a fairly agnostic perspective on how we implement this and really anchoring on those sort of 3 principles. What we found is every organization is not unsurprisingly a little bit different. The tools they could use, what they could bring into their stack. We tend to work with a lot of large enterprise clients that have really restricted environments. Maybe happy to connect with you offline, Ray, and share some of the tooling that we've done. But yeah, I mean, we try to create principles in a workflow that can translate to whatever stack an organization itself is using and adhere to their world without introducing with minimal introduction of any new tooling if we can.
Great. Thanks, Andy. All right, next one up from Rodrigo. We have a question on, I have been having issues creating something like this. When consulting for multiple clients, each one has its own rules and defining rules to rule them all have been an issue. Some don't even have version control. Just wondering, how do you manage this issue?
That's a
Mike, do you
good
want to
one.
take that or happy to take that is a good one. I appreciate the question, Rodrigo.
Yeah, it's definitely tricky. So, I mean, you really need to take each client individually. So, so your company is going to be the thing that you're focused on, right? So what are the challenges within an organization? I mean, we like to start small. Right. So we like to find a project with a team that's very passionate about what they're doing and develop something that works for that team and then expand from there. Right. So trying to go across the entire organization and find something that works for everybody at the same time is usually going to be very challenging. It's just a big change management problem, regardless of the type of change you're trying to introduce. So starting small, finding a good example team that can execute something and get it to work and show the results is the important first step to get everybody sort of on board, and then you can take it and build on that from there.
Yeah, and maybe I would just add one thing that like I've seen us do practically very recently is creating like a single repository, like a global repository that has kind of global skills, global context, global rules, and then importing that as a submodule into the different projects you might work on. And so, Rodrigo, in your case, where you have different clients, you might have your toolkit that you build out in a central repository, and you would import that to get started quickly with a given client that you're now working on. And then within that repo that you're using for that specific client, if there are unique variations of whatever it is they need, then you can have that live locally there. So that's one option.
Great. Thanks, Mike. Andy, we'll move on. I'm conscious of time. We've got a few more minutes left. Question from Rajneesh. Hi, Rajneesh. I'm curious, what are the best practices for evaluation major changes to the shared context? For example, adding observability across the system. Who wants to take that?
I'll give it a stab, and Mike, maybe you'll color it in anything I'm going to miss here. But yeah, I mean, it's a good question. Managing changes to shared context is probably the most challenging part in all this. And how do you like stay aware of changes and cascade them down, right? Especially when they don't live within the immediate vicinity. Observability, I'm not sure what you mean by that. I mean, I know what you mean, but I don't know if you mean it observability in terms of context or observability in terms of code. If it's in terms of just context and source documents that feed into like a local repos context, um, there are a couple of ways we work through managing that. There are some tools in that case that are pretty good that can observe changes in files and cascade them downward and trigger actions in terms of code, large code changes. Um, so large code changes, I guess, is a relative question. One of the core philosophies about all this, by the way, is that if you want to use AI to develop software, you should be conscious of its limitations and how to best use them. And so if you have some one giant monolithic code base, AI is going to struggle to like really comb through all of that. Not that it can't, but it's going to be, a lot to comb through to then go and evolve context. Taking a more of a modular microservice-based approach to how you tackle a monolith or decompose it or how you handle a future project will give you the ability to manage context and observe code changes and update the context based on that more easily and clearly.
Great. Thanks, Andy. We can always follow up with Rajneesh as well. I'll move on from that just so we can get through some of these other questions. But thank you, Rajneesh. Um, okay, the next question from Amitava, I think is something we can just share afterwards, is please share the GitHub repo you referenced here so we can send that out as a follow-up, I presume. Great. And then Shivi, where does a program manager, project manager sit in here? So maybe this is a good question for Mike, because I know this is a topic close to your heart.
Yeah, it's very interesting. I mean, obviously, it's very organizationally specific, right? So, some organizations have a more modern product operating model. Other organizations are a little bit more old-fashioned and have project managers throughout. So I think typically they're going to have we're going to start with them in their current role where they're at. And the reason I was part of this presentation is because that stuff that happens early on at the very beginning is super important, right? The amount of leverage that you have as a project manager or as somebody defining what it is that you're building increases exponentially once you have AI, right? Because everything that happens after that is accelerated so much. So it's very, very important for that person to have a prominent role in what's being defined and to be very active in helping to build the context out. And so I'm not sure what you mean by where they sit, but I think that I think that there's been a lot of talk about how these positions are going away. It's just not happening at all. Like the openings for product managers, for example, are actually increasing. There's more open product manager roles in the industry, just overall in all industries than there was before AI was out. So, and it's just continued to increase, which is very surprising, right? I don't think most of us would have predicted that. So there's a huge role for them to play in this, and it's becoming more and more important to get this stuff right. So I think that it's super important, but where they sit is definitely the left end of this process is becoming the more important piece of it, which is what we were trying to get across here in this presentation today.
Great. Thanks, Mike. We're going to squeeze in one last one because there's a few people have voted on this one. It's from an anonymous attendee, but how long might it take for this setup to be up and running and introduced to a new company? Good question.
That's a good question.
1 minute to answer this before the webinar ends.
I would say it's pretty quick to get going, like the foundations of it, and start seeing immediate impact. I mean, like you can get a baseline there in like a week, and probably 2 weeks, you have a pretty good curated set of context, skills, and governance. The largest hurdle is the human element. And so implementing the change management around working in a new way and thinking about context as part of your code base. And so that requires repetition, training, and curation, and then making sure your skills and whatever you learn along the way evolve. So just getting a baseline out the door is actually pretty quick. But then it's sort of the ongoing maintenance and the change management of that that usually takes maybe a month or two to really like cement and get folks driving.
Great. Thanks, Andy. I'm sorry, we've got a few more questions, but the webinar is going to come to an end. What we'll do is we'll follow up. We'll take a copy of those questions and follow up afterwards. But thank you, everyone, for joining us. Thank you, Andy and Mike. It's really insightful talk. I appreciate it. Thank you. Bye.
Thanks, everyone.
Thank you, everybody.